Sure. All right, my bad. I'll do it.
You want to see it?
My first time.
I'm just, actually, if I could just put this park beside you, Lexi.
Sure, that's fine.
So whatever you guys say will be recorded. I don't know if
Okay.
we're live streaming or not.
I'll guard a.
So Ben,
Welcome, everyone.
Nice to meet you. Yeah. You came from Newmarket?
Yeah, I can hear you.
Work remotely for Upland Software in Texas.
Okay. So you're a programmer?
Yeah,
Nice.
Yeah.
What kind of code?
I mostly manage their teams now, but I started as in .NET. Now I do a little bit of everything, but
Okay. Sure. The manager of dev teams is likely the most powerful person on the planet,
well,
shortly.
I don't know about that.
Well, it's probably not the dev.
Say it again.
The manager of dev teams, right? The project managers is likely the most powerful person because they're the ones that understand both the technology, the customer requirements, all the things that go into the development of that thing. Now, the problem with devs is the devs are very they're traditional devs, not agentic engineers, just to be clear, but traditional devs that don't pivot to this idea that suddenly you can build anything anywhere, are very narrowly focused. So that's why I think the dev manager is the puppet master.
I think the most interesting thing for me is trying to figure out like what gets in the way. Well, when devs just want to do their stuff.
Yeah.
Right? And a lot of this is helping, but that's kind of what I'm trying to understand.
Okay.
So
And what are you coding, like vibe coding or anything?
oh, I'm building stuff. I mean, I'm kind of just experimenting with a lot of stuff. RAG systems and experimenting with some multi-agent stuff, but it's haven't really found a really good unique idea yet, so.
Well, you can just try a million things.
Yeah.
And see which one
building
sticks.
stuff, so.
Yeah, but we're in interesting times right now. The last couple of weeks have been, extraordinary in our space. What is the big open claw, what do they call them, molten bots, and that's been sort of the aha moment for a lot of agentic engineering that we've seen. But in our crew, we've been doing that for 3 years now. So for those who are new, we do this every second Tuesday of the month where possible. Sometimes in the summer, that's a little questionable, but we're the geeks. We like to be the outliers. A lot of the stuff that we've discussed and shown, comes to be at some point, or maybe not. That's Brad.
Hey, everyone. We just,
So Brad is one of the co-founders and creators of the Agentics Foundation. How many cities are we in exactly?
It's
A lot.
It's a lot. I think tonight alone, but there's 4 different events going on.
Yes.
So this is the Toronto head office. Rube's our founder. So thank you, Rube. So, and this, just to give some props, Tribal Scale is right here. So they're our first sponsor that is kind of donating this space for us. So I have to say that. But yeah, Rube, I think today you're going to do some show and tell some amazing stuff.
Well, we're going to do some of that, and we're going to do a little panel.
Awesome.
We like our panels,
Yeah.
random chit chats like Ben and I were just doing, a lot of this is just trying to navigate the space and figure out what people are thinking and see where it's all leading us and that kind of stuff.
Yeah, and if there's time, Nick has the earthquake, and Rob has something pretty awesome
Okay.
that they'd like to show. I don't know.
Well, and if any of you guys want to show and tell anything that you might have with you, we're always game for a good demo, even if it breaks halfway through. That's kind of our calling card.
It's supposed to break it.
Yeah. If it doesn't break at some point, you're not doing it right. All right. So yeah, for a lot of you guys that I'm gonna start quickly with mine, then we'll jump into a panel, then we'll do some other Q&A. I won't monologue for 2 hours, I promise. So for those that are not new, or new here, I've been working on an agentic chip over the last 6 months. This is my first prototype, and I'm gonna ship this on Pi Day on Saturday, so March 14th. So basically, it's a system that allows you to create a kind of real-time learning nervous system. Earlier I was showing you guys this picture here of a Wi-Fi that sort of looks and understands its surroundings. Now, the reason why the system looks and understands its surroundings is because it's always learning. So what it's looking at is the space in between, where a lot of AI has been around the idea of zeros and ones. Most of it's been one, right? Is it on? Is it available? Can I see it? What is it? Why does it matter? Those are all ones. My system is focused on the zero. My system says, what isn't there? And when something intrudes in the space that's not there, why? What's the minimum cut? It's the algorithm's min cut. Now, when you do that, the world around us is very noisy. There's RF signatures coming from my phone and from Wi-Fi, and every single one of you are putting out energy of various sorts. That's really hard to decipher. What the interesting thing about this is what it is, I train the model to look at the ambient space that doesn't have anything going on and look at the integrity of that system. That says I can detect certain things out of that system without having to look at the entire system. So think traditional AI, answer everything, give me an answer based on the most probable answer for everything you were able to look at. That's what a GPU does. My system says only look at the things that are meaningful and tell me when things are outside of the bounds of that meaning. Heartbeats are not, we're going right. Wi-Fi signatures that don't quite look right, that form the basis of people. I can detect the heartbeats. Well, in this case, it looks like it's not working. They're dead. But in this, I can look and find those different signals, and I can see those by looking at the inverse of that problem. The great thing about zero is it doesn't take any space. It's the absence of something. It doesn't have anything. So when you're looking for things that aren't there, it's light, it's fast, it's ephemeral. And then when things are different, they snap into place. It's like a spark, a neuron. This essentially is a nervous system, looking at all the properties of things outside of what they should be. A trading system, mineral deposit, space exploration, satellite movement, swarms of agents working and collaborating with each other, and asking how are these things and how do these things fit together? Now that I was able to do that concept, I was able to do it lightly. The project that underpins the chip and the other things I'm doing grew out of sort of the work I did in RootFlow. So RootFlow, which came out in June of last year, it's been downloaded some crazy amount of times. It looked at this idea of using agents to communicate and cooperate with each other, but not in a way that you think of like a hamster wheel. And a lot of AI is this idea that you churn through the tokens, asking the question, am I there yet? Is it done? Is it right? Right? It's asking and churning and making sort of noise when it doesn't have to. What I do with my system is said, if I can understand how it needs to operate collectively to get a problem solved, can I then remember the optimal path to how I solve that problem, then use that next time I see that problem, which actually works really well for coding. Because a lot of coding, at least when you're using Claude and other tools, is basically, oh, it broke. How can I fix it? Oh, it broke. Oh, it broke. My system, before it ever gets to the point of saying, is it broken? It says, we fixed that last week. We don't need to ask. I already know. I don't need to ask the language model for the answer, right? That is a sparse problem. Spiking and sparse means I'm only looking for the problems and giving you the answer when I realize that it's within the bounds of that problem. It's light, it's fast, it's not prone to hallucination because it's deterministic. A traditional language model is probabilistic. It tries to answer the most probable answer to a problem, but what it doesn't do is give you the same path to answer that problem every time. It's probabilistic. The approach that I've taken, which creates a graph in using mathematics, is grounded in the mathematics of the vector space it sits within. So it's bound by mathematical principles, not by probability. So why that's important is because you can take that concept and you can create a seed. The seed allows you to recreate everything that happens between the moment it starts and the end result and cryptographically verify it and do it more than once. Yeah.
Does it reinforce?
It reinforces, exactly. So it uses a form of reinforcement. Every time something's good, I give it a few extra points. Every time something's bad, I take away some points. So over time, the best rises up and it remembers the trajectory of the best path to get back to that point in time, space, or information. Heartbeat is out of sync because it usually is in sync. I only care about when it's outside of that sync. If that makes any sense. So it's the opposite path. Yeah.
Could you explain, like, if we create a normal agent, it might be follow these 5 steps, and it usually starts going off on its own. How is this different?
So this is grounded. So a lot of the so spec-driven development's become very popular with sort of cloud-based development where you write an MD file, you give it a PRD, product description of sorts, this sort of follow. The problem with that structure was it was ambiguous. It's like, I want this trading application that does a bunch of things and solves a bunch of problems for my customer. But what it didn't do is bound that in 2 really important parts: an architectural decision record and a data-driven design. So when you look at how I build my things, which is, you opened up a nice can of worms here, you'll see here that I've got a folder dedicated to, where did I put it? V3. And I think I called it implementation in this one. And you see ADRs. So every architectural decision that was ever made in this to build this, which is 250,000 lines of code, I get, I don't know how many hundreds of thousands of downloads a week, a lot, was made and defined in this document. So if we go into the random one, MCP security features. So what this is, it allows me to look and understand all the decisions that were made at that point. So if I need to come back to that point later, let's say I have a security problem I need to fix, I've got a record of all the things I did to solve that problem, and how it was solved, when it was solved, and how that affected other things. This creates a graph. Each of those architectural decision records is interconnected to each other through different forms of sort of connection. That forms in that vector space I was telling you about. That grounds the system so it can understand what it's built, what it needs to build, why it built it in the way that it did, and can it build it the same way going forward, which keeps it from drifting into weird rabbit holes and stuff you don't want, the kind of AI slop you see around, right? Where there's dead code and backdoors and just structurally inefficient. This approach allows me to build absolutely anything I can possibly imagine. So that, if you want to go down the Root rabbit hole for a moment, you're going to see. Well, actually, I'm going to launch a collective intelligence system later this week, which I'm calling Pi. So this is kind of the manifestation of a sort of global distributed anti-AI that learns, adapts, and understands. Think of like Wikipedia with a common mind, where people can connect to it, share information. It takes the sort of personal identifiable information out of it, but learns the structure of the things in which it's connected to, and then shares that with everyone else connected to it. And to do that, all you need to do is connect it to your MCP. I'm actually launching this on Pi Day, which is on Saturday, I guess. But this uses all the parts of my stack, and I deliver it in probably the nerdiest way possible. But essentially, I'm using, again, a combination of vector graph and other structures with a kind of agentic loop inside. The agents are the parts that learn, they adapt, they understand, they know, but they're ephemeral. They last for moments. Like these moments could be like nanoseconds in length. You can check that out later. And I made it. The URL works with both PI, and if you're super nerdy and want to figure out how to type Pi, you can put that in the URL as well. I got that to work. Oops. Yeah, there we go. That might be my favorite URL of all time. Can't believe it worked. Right? Have you ever seen Pi as a subdomain? But I like that. Looks really good.
Be really long to type out, though.
Who the hell knows how to type it? But if you know where it is, it's like a secret sort of back dark entry. All right, so back to my chip. For those that came around, the chip is essentially all the things I've built on a tiny, this is a Pi 0. And I put essentially my root vectors, all the things I was just showing you briefly, onto a single little sensor device. And that opens up a world of opportunity for cheap, efficient, always running AI. So when you think about building agentic systems, and let's say you want to build a trading bot for do stock trading. If you're doing a decent trading bot, you're going to have at least 50 to 100 different bots always running, looking for opportunities and adjusting, adapting, doing whatever they're gonna do. And that's if you're like, and that's if you're poor and broke and don't have any money. If to run those 25 trading bots all the time for an entire month, you're looking at, let's give a nice round number, 100, right? Let's say you're looking at 100 different, variable things to invest in, which would be reasonable, even though it's not that big. If you're on Google, that's going to cost you minimum about $25 per agent a month. So $2,500 a month, that's $30,000 a year to just, look at 100 different trading bots. Now, with this approach, I'm running this on a tiny little bot, a tiny little device. This device is always learning, always understanding, and always and looking at what it needs to understand in terms of signals around it. That could be your health. That could be a group of stocks. Anything that connects to it can then learn from it. So I just plugged it in. Let's go to my, let's go down here. So what happens is it connects as a drive here. This is a mount. So you can just click the open button. That then connects and configures the environment. So you're now connected to essentially the world's most fast and efficient sort of AI. You can see I'm connected, it's paired. Then we've got, sort of quick start. But what can it do? So we've got one format to rule them all. I created a format that basically is a single binary that contains the storage. So that think of like the data and the graph and the attention, all the things you need for sort of doing AI to learn and be used. Then it also includes an embedded kernel, which you can put things like Claude Code on or Clawbot or whatever they call, whatever OpenClaw, whatever you want to call it, directly in a single package. So now that this agent can run directly in its own little sort of environment, quarantined from everything else, it gets its own networking. If you want it to be, a drug analysis bot, you can do that. You can then put each of these little agents and have many of them working in unison. So this box could do 10,000 agents sitting and looking and understanding the world around it. I'm making this, the seed for my seed of my seed company, we're putting out $131. So that means once you spend $131, it'll run forever at no incremental cost. There's no subscription. It all runs on this little box. It has 4 cores and some other various stuff on it. Now this is part of my sort of, so here's the vector information if I want to see different queries, and it's basically creating a kind of nervous system of anything connects to. So this again can be a heart monitor. It could be anything that has a signal it needs to learn and understand. Now, as part of that, I will be coming out with my chip in a few months here, but I'm launching this as part of our seed round for Cognitum. I'm going to wrap up at that point. Cognitum is my new startup. It's coming, and we're launching this on Pi Day. So this is the first of several devices we're going to have, and here I'll give you guys a little sneak peek of what the rest looks like. So always on agents, blah blah blah. I'm not going to go through all the materials here. Nervous system. So first the chip, and then we have a little appliance, and so we're launching the chip on Pi Day, which is what I'm showing you here. I'll run on basically a AA battery. And then we've got our appliance, which will basically it's just a much more powerful version of what I'm showing you. And eventually we'll have a chip which is going to fab at Global Foundries. That'll have 250. So imagine 257 of these. Like that would be the size of like a poster on a single 3 centimeter chip that runs on less than a AA battery, and it'll cost you a few bucks a pop. The idea is the AI will be infused into everything and everything around us. Yeah.
Sorry if it's down updation level question, but if I understand it right, is this device, it's like let's say if I need to run an open initially they launched it and I need to buy a Mac Mini to put that open on it.
You don't need a Mac Mini, yeah.
So this device is going to replace all that, and I can put
You can put
open class and other agents on this.
Yep, you could run multiple claws on the device. It's got a 4-core processor. It's a 1.3 gigahertz processor. It's not the most powerful, but for things like OpenClaw, if you don't have a desktop, you don't need that all that power. And you could run multiple. You could probably comfortably run OpenClaw 4 to 8 of them on this. Always learning, always adapting. You could connect it to your security system and have it, monitoring the Wi-Fi signature and say, is someone coming in my house? You can monitor the environment for sleeping patterns, it can even pick up on signs of epilepsy. So it can pick up on the signs like before you have a tremor, it picks up the micro tremors. It can pick up on the little minor sort of fluctuations in the information around you. You can connect it to your HVAC system, whatever. And essentially OpenClaw, if you want to use that, would be managing it. Yeah, that's my presentation. I know we got a lot to cover tonight. What I want to do a little bit tonight, is, and this is an update for shameless self-promotion, but what I want to do tonight is yes. You got a question?
Your other website, your URL by going by the copy.
PI. Yeah.
And the alternative to apply to them.
Well, I didn't auto redirect. I thought I wasn't convinced that URL would work for everyone. I've never seen a Pi URL before. So I should auto redirect it, but I don't know. It's all hosted on Google or whatever, Google Cloud.
Very cool.
Yeah, and you can, if you've got if I actually just go back, I covered a lot of ground here. If you are interested in that, all you need to do is add it here. Let's go back to this. I'll skip this. You'll see that there's a guide. Yeah, you generate a key. So this creates a unique cryptographic key. No bullshit crypto involved, by the way. And then you can go to MCP and you can just add it to Claude. And now you'll be part of the collective intelligence. Again, I strip out all PII. You're not leaking any keys. Yeah, it's all open source. You want to check out my code. It's just it's a little crazy. It's a self-learning, self-optimizing brain of sorts built on all the stuff I was just showing you. Oh, I'm there.
You want to? That was mine. Was actually right on you.
Oh.
We can share your screen. Do you mind to join that?
Oh, you did. Well, you wanted me to join. Oh,
Why
yeah.
I join?
Sure. Why not?
If you want to share your screen on it.
Or anybody want to join our panel? It doesn't have to be as nerdy as the stuff I'm showing. We can talk about anything you want.
Recording in progress.
All right.
Hmm.
Two perspectives.
I can join the panel.
Who actually?
Hmm.
All right, I think I'm muted. No, not muted. You. There we go.
Speaker, your speakers.
Oh, because you're plugged into the.
No, guys, I'm getting the audio's off, but my audio's down. I don't know why I'm getting audio. Building AI is easy. Turning the audio off, that's hard.
There'll be another mic on some.
As the IT guy in my neighborhood, my neighbors come up and like, oh, you're good with computers. Yeah, I can help you with your printer, and I always do. I'm always happy to help with printers, but to say I work with computers might be the understatement of the century. But all right, you guys want to do a like panel? What are you thinking? Rob, you have any good topics you want to cover? Anybody want anything you guys want to talk about? I don't want to do the topics. I want to hear what you want to talk about. Anything?
OpenClaw meets reflow.
Maybe broader, like people like what the hell's Agentics? Am I gonna lose my job? Or like, what's it all mean? I don't know, like.
What jobs are safe in 5 years from now? How to upskill?
Or we could say, what else to make it agentic?
All right, you want to come on? We got a first volunteer. Come on up.
We're gonna talk about it or?
Yes, but we're gonna talk. We're gonna talk about it. And I'm sharing the wrong screen here. Let me share what. All right.
What topic are you discussing?
Well, I'm looking at like, the past couple of years, it's been like developing real fast, right? We're making everything agentic, right?
Yeah.
But I suppose there are various different industries that are really left behind,
Mhm.
but not being turned on onto agentic ways, and they're obviously that's probably because like there's a lot of like, a lot of those industries, the data is really offline, right?
Mhm.
I'm running an AI company here in Toronto, so I get approached by a lot of companies asking me like, hey, I do this in agriculture, I do this in like, I have a factory, big factory turning like billions, but like, we wanna do this and we have like 25 employees to handle only that little task. And as a matter of fact, an LLM can really handle really well, right? But like the data is offline, it takes them a lot of effort to really turn things into computers and train it and come with all the knowledge base and so forth. So I recently realized that we thought we'd really make everything agentic, but like there's like a whole shebang of things
Mhm.
that is behind the scene that is possibly is emerging right now, and it's like allowing us to turn a lot of new ideas into reality.
Mhm.
You know, I wanted to hear what you guys think of that.
Yeah, I can actually talk about that as well. So in relation to,
Well, I'll make you guys comfortable.
I mean, I might put you guys too close, you know.
There you go. There you go.
The personal space.
So
And what would be nice is if you talked about how all the smaller businesses, you have that guy, that girl, that brain that is the owner. How do you help those people?
So
We need one more.
Oh, yeah, who else wants to go up? We got 3 chairs.
Come on, guys, it doesn't matter. Just go ahead.
it doesn't matter, yeah, there.
Oh, yes, Shen, absolutely. Welcome back, Shen.
Oh, what?
All right.
All right, let's look at the discuss.
Okay, so first of all, I just want to say that thank you for bringing up that point, because what I think that really AI and Agentics now, it really brings an increased level of capability, especially for people who didn't know much about software engineering before. So for example, I myself, so I'm going to have a publication in Canadian Pharmacist Journal in about the end of the month. And really, this publication is really foundational because it stitches together a lot of different sources together in order to basically get data that basically the pharmacy sector, especially in Ontario, never really had. And by using public information in innovative new ways, I'm now able to share this information publicly for the benefit of better healthcare in this province. And then also potentially globally as well, as my new methods can be used by some other countries internationally for the benefit of their own population. Now, additionally, in terms of AI, I think AI really gives people, especially with domain knowledge and the ability to think about other things that are different than how a typical technical person thinks about them, and gives them additional skills in order to implement different solutions and different problems that only they see in their industry. And then by having this additional capability of technical skills, which AI and Agentics now provides them, they're able to evaluate the progress of their own solution in order to lead to a benefit that not only helps them themselves, but also helps other people of the same profession.
Well, and for those who don't know Alexi here, he's OG for our Agentics crew. He was here the first one, right?
Yeah.
Yeah. And so we've seen you grow through sort of the early stages of your agentic sort of evolution. You know,
Yeah.
what are you building? Like, what are you building with right now?
So what I am building right now, so I have a startup as well. So I'm the CTO of that startup. And that startup is essentially using multi-agentic RAG in order for the benefit of doctors and also pharmacists in order to help them find the information.
Now, the very important thing about healthcare is that ultimately the decision has to be on the part of the provider, especially for healthcare. Because although it can help the doctor or the pharmacist identify the correct information, and through my own domain expertise, also evaluate it to make sure that it's useful for the provider involved, I also have to make sure that all the information is accessible and verifiable for them. And so I've seen great uptake and the need for pharmacists, because pharmacists are greatly also have a lot of administrative burden. I'll give you a concrete example. So for example, in Ontario, we have the Ontario e-formulary. And for the Ontario e-formulary, it basically tells you that how much for a particular drug being dispensed at a pharmacy does the government actually pay back for that particular medication. And it's very convoluted, because it's something that a pharmacist only understands once they're in practice. It's nothing that's taught in schools. And so you have general benefit medications, you have medications.
So Lexi, if I can interrupt you
Yes.
a moment. You're saying that if you screw up, people die.
No,
How-
well, okay, I'm talking about economics. Well, the economics of community pharmacy practice right now. So
and how's that relate to Agentics?
Agentics. So that's the interesting thing. I was just about to get to that. So in terms, you have a lot of different it's very convoluted. And but by using Agentics, and using the domain expertise of a pharmacist, you're able to bring together this information that they have. And then AI and Agentics can help to think of a solution in order to not make that process convoluted anymore, in order to make that process more simple. And by making it more simple, other people can also use the same solution to lead to better population health in this province.
I like that. Jen, how's it going?
I mean, good. Should I do an introduction first and then bringing that topic?
Yeah, just a new basis.
Okay, sure. My name is Xiao. I'm a founder. I'm a serial entrepreneur. I started multiple business before. Some venture back, some are not. Currently, I have my own software development firm and mainly doing Gen AI implementation these days because it's so popular, as you guys may know. So, and we also work on some of our own products, AI powered products.
Oh, we got the sound of the mic.
Oh yeah, we got a mic. Good. Yeah, so I think the topic I want to.
Oh, yeah.
Yes, too loud.
Go Mariah Carey or whatever.
Okay, so yeah, I think the topic I want to discuss is how to adapt AI in other industry rather than coding, other than like the software and tech, because whenever I talk with people at this kind of meetup, everybody more or less are up to date with AI. But the thing is, if I talk to someone in e-commerce, someone in I don't know, in supply chain, someone in a very not technical field, like all they are doing is chatting with ChatGPT still. So I think, and also the fact that did you know that only this year, we're just March, there's already more than 10 major foundation model updates already. I was giving a talk at the developer conference. I think on my slides I said 8, but now we got even more. That was like 2 weeks ago. Yes, and yeah, it shows that how fast, and also especially the last few releases, Gemini 3.1, GPT 4.5.4, and also Obvious 4.6, right? So it seems that every release somebody's with a new best model over there. So yeah, and I want to discuss how to keep up to date, and then how to make sure that the rest of the other industry, which is 90% of the economy, will adapt to the fast-pacing change of the AI.
And keep up with all the daily sort of noise and updates and changes.
Oh yeah,
That's a really good topic.
yeah.
And you're a AI company founder, is that what I heard
Oh, I
earlier?
am, yeah.
Well, I want to hear about that. I'm here, Brandon, that's.
All right, quite similar to yours, actually, I co-founded an AI company about 6-7 years ago. So we were, like, ironically, I was lucky to study AI like 10 years ago at the university. So like from education, I always wanted to like, automate things and never wanted to like go through a rigorous process of like have to go through this. I felt like we either need to be us becoming a superhuman or we need to make a machine that is able to automate things. So yeah, and then and I also have a startup that we're recently launching the MVP, and it's about business intelligence and customer service automation. What it is trying to do is trying to solve the problem of you understanding what's going on in your business. There's a lot of transactions, there's a lot of activities about your clients, interactions, and so forth. It is all like most of them are collecting dusts. Ironically, a lot of big businesses, $100 million turnover businesses, they're not able to fully understand what's going on in their business when it comes to all the interactions they have with their clients, what the pain points are, and so forth. We all give reviews of like why I'm leaving this company, but like it collect dust until like a year ago, somebody says, you know, a year ago you left off and you're gonna continue with subscription, what happened? But it's too late, I already moved on with some other products, right? If there's another tool that is able to pick up exactly where you left off and try to understand the actual pain point and take an action against it right away, it's gonna possibly really solve big problems. So that's what we're trying to solve here.
It's awesome.
Yeah.
And you're like just getting going, so you're looking for funding, like what?
Well, right now we got the raising, we got our first 2 paying clients, just past week. Yeah, we haven't launched yet, we just told a couple friends. Thank you. Yeah, appreciate it. So, I mean, I'm a serial entrepreneur, I've had 3 other businesses, 2 failed, 1 I made a buck. So that is, I'm putting a lot of that money into bootstrapping this with my co-founder. So, yeah, that's what we're trying to solve, and it's very interesting what we are discussing here. I came here like a year ago once, and this is my second time after a year.
Well, welcome back.
Yeah, thank you.
Welcome back. Thank you
Yeah.
for joining.
I think that the one thing I want to point out when it comes to a lot of these, because everybody pitches, you know, an AI startup these days. The key, I think, is doing it more cheaply than your competitors. Because the one thing that everybody's struggling with when it comes to building these AI systems is it's really expensive to scale LLM-based AI, you know, solutions. So if you can figure out a way to do that way cheaper, faster, and easier than your competition, it almost doesn't matter if you're, I won't say better, you should be better, but it doesn't matter if you're better if you're cheaper. Because they can't compete.
So actually, in regards to the cost, I want to mention 2 points. Actually, so first of all, mine is, it's too loud. Here, hold it. Okay, so I don't think I need.
You ever see Mariah Carey, like she's doing like this thing, I'm not gonna say, but you grab it, you know, where she's like.
I don't think. Hello. No, it's fine. I just natural voice. Okay, so I have 2 points I want to mention in regards to cost. So for my startup, what I'm doing is a little bit different than tech. It's really the amalgamation between tech and the different concepts that I have learned from Rube. Now, I do have to say that I am very thankful for Rube, because in this process, in his mind, in the technologies and what he does in order to achieve the solution that he does, it's very innovative and it's very elucidating, because that way I actually find out different patches of my information that I didn't know, and then I'm able to think of new and innovative solutions that I can apply to my industry and to my problems, or to even other problems as well. So in terms of cost, so first of all, I'm basically servicing healthcare professionals, in particular pharmacists, across Ontario and across Canada. So far, my startup has 700 registered users. We have 40 paying customers, and we have a partnership with Ontario Pharmacists Association and Medisys. And then we're also branching out internationally as well. But right now, because we are in a healthcare provider and not for the general public, so right now, what iSkyra is, it's a clinical decision support for pharmacists and other healthcare professionals. However, we're starting off with pharmacists right now because that's where we have the most relation, and then we're trying to expand into other healthcare professionals as well. But pharmacists, they're not as many as normal people. And because they're not as many as people, because a single pharmacist can handle 1,000 to 10,000 patients. And in that case, the costs are much down because the volume of the traffic that we have to have is much less. Now, second of all, what also really helps is that we went into a startup accelerator program. And since we were inside of an accelerator program, we were able to get Google Cloud credits. And in this case, the Google Cloud credits have really helped to subsidize our costs while we make additional benefits. And then we are able to actually be in the net positive as well and be able to make money. Now, the amount of money that we make is still small compared to all these big startups, but rather I'm more interested in the amount of benefit that I can have to population health and improve the health of both of patients and people while also improving the provider experience. Because a lot of pharmacists and a lot of doctors as well have also they have a number of administrative hurdles. What someone, especially in healthcare, notices with the problem with the Ontario pharmacist system is that everyone is secluded. The nurses have their own electronic system, the doctors have their own electronic system, the pharmacists have their own electronic system, and none of the data is shared. Nobody knows what's going on and where. Now, the province has tried to solve this multiple times, most recently with Canada Health Infoway, but then that also did not very end.
Let's bring it back.
Oh, yeah,
I love pharmacies and that's.
Yeah. Okay.
All right, quick,
Yeah.
the point of tonight is to learn about AI and agentic engineering and sort of the future of what we believe to be the future of tech. So let's refocus for a moment.
Okay.
So let's assume for a moment that all the stuff that we're building is the future. I think it is. And we're looking at a sort of major disruption in how we work, how we interact with technology, what the technology even does and how it understands us. What does the world look like in 10 years? I don't know, I want to hear from the audience, like, where do you think this is all going? Like, what, are you pro, like, utopia? Looks like, I think, the best version of Star Trek? Or are you dystopia? It's some dystopian version of Star Wars and everyone's out for themselves, yeah.
Maybe in 10 years, large corporations. And they'll be existing just fine, but maybe only about a third of the employees.
You're dystopian. So he's Blade Runner. All right, do we have, I love like AI analogies, yeah.
There might be a scenario where many startups can come. You've seen the last language more, but custom tailored to each specific use case. In the community, they're trying to serve. And large corporations have the capability, but on-ground people who are who know the technology could take it to every individual and tailor it to their particular needs. I think the difference, like how Instagram or social media can there at some point. At some point, we have celebrities. Now everyone is in the same trend, like everyone can create custom foods for the specific set of audiences who they want to serve.
Yeah. You're not as dystopian. And who else? What's the future look like? There. Where? Oh, yeah.
Just do a business.
Here. Okay.
I think a lot of right now is trying to make big corporations. Like, I don't know how many corporations, but big problem is the speed at which they can. I think with the next AI and all that, this is maybe 5 more years or 10 years. 10 years on kind of on the dystopian side. But in the near term, I think the speed at which they explain, for example, M&A integrations happen. Corporations spend billions of dollars buying a company, take 10 years to integrate it, I would even realize value at the years. I think with AI, agentic AI, the speed at which we're going to get onboard an acquisition, for example, it would be like 110, 100, which allows the big organizations, kind of tries to do dystopian thing. That allows these big organizations to just move so much faster as if they are a startup in the places that matter. So get take advantage, you get big corporations just getting bigger and bigger, way faster than ever seen. And I don't think regulation.
Yeah.
There's a term for that back in the 1970s. I can't remember the name of the economist out of Latin America coined it, but it's called technopower. it's the spiraling of technology and, the accrual of capital to reinforce the, velocity of technology, which speeds up the accrual of capital, techno capital.
Well, I've got an opinion as well, and I can't help myself but share it. So, you know, I'm the worst mix of a, you know, I don't know what you wanna call it, a techno-socialist and a sort of altruist, right? I give away almost all my software. It's used by millions of people every month. And I don't expect anything in return. I just feel like it needs to be out there. Now, why would I give away so much and without getting anything really in return other than a lot of hate on X, right? So the reality is, I think this technology has the ability to, I don't want to use the word democratize because it's sort of loaded word, to equalize a growing level of inequality that is purposefully being sort of manufactured. When you look at what's happening in the AI space, you see these massive data centers being created that take almost the size of Manhattan, for in the case of Meta. And they take huge amounts of electricity, huge amounts of infrastructure, capital expenditure, billions of dollars, moving from one giant company to the other. But only between a small group of those giant companies does that money actually flow. It's insulated, making those who have the power, the capital, and the connections richer than ever. I'm like, fuck that. So let's give away my code. And so over the last 5 years or so, I've been giving away billions. At this point, I'm at 50 million lines of code. Every time someone looks to do a patent, they say, oh, I'm going to create a swarm. Did that 3 years ago. Or I'm going to create a vector, blah, blah, blah. Did that. So that creates a kind of pattern, a kind of a prior art quilt of all the things that I tried and made available and didn't kind of move on from. Now, if anyone, if any of these companies want to go and use or create a patent that said, I don't think that technology that monitors heartbeats through Wi-Fi should be made available to the public, too bad, I already published it and it was trending over the weekend, right? That provides me and everyone that I want that be empowered by the technology an open and free way to use it without the control of some giant company that's trying to make the rich richer. I'm a techno-socialist in fairness, and I'm not everyone's cup of tea. I get it. Now, what does that mean for me? Like, I'm in the midst of starting my own startup. I'll be up there. I just pitched you on my startup. It's a chip. It's a chip that's super cheap, often super low power, doesn't require a giant data center, you know, constructed in the backyard of the world's largest catalog, right? It means that I move the compute not from some central arbiter of intelligence, but to everybody who needs that intelligence, regardless of their place in society, the amount of money they have, which in my belief makes the world better because we have equal opportunity to the fundamental shift that's happening because of this technology. Now, I might sound like a lunatic that's going on a rant on a random Tuesday night, but that's what I believe.
Yeah. David Tushek. I love that. And it really pairs with what I was going to say. So Josh Jeffrey is the managing director of a company that I'm co-founder in, Forthway. And you know, have you guys seen the red dot? It shows if there's a grid. It's like
Oh, we got the 0.1%.
0.1% of people are using. You guys are the 0.1% of human beings. Probably out of 8 billion people, right? That's the little red dot in the corner, and then there's a few that are orange that are actually using LLMs, using AI, you know, generally. And then there's the rest of the world, right? Who's just not. And he wrote an article, Josh Jeffrey did, that basically talks about the responsibility of the red dot. And it's you know, I love what you're saying, right? In Canada, we're very socialist, and I also identify as a social technocrat. But this is where we're at. There are humans who are using the, you know, some of the most powerful technology that the world has ever see that humans have ever developed to do things that are not for the benefit of humanity. And then there's other people, hopefully us, hopefully the people in this room and in other rooms happening today. Around the world.
Four of these happening all over the world right now.
Yeah.
Tonight.
Yeah,
So-
that's right, for the, yeah.
Yeah, and so hopefully in this community and in other communities like this, and actually that's the truth that I've seen. I've been in amongst the AI, Agentics, Gen AI community for the last 9 months, and that's overwhelmingly what I've seen from speaking with people around the world. I'm speaking with hundreds now of AI leaders from around the world in setting up our company, and the amount of resonance that there is towards using AI for good, for the human benefit, not for, like the gentleman back there said, to get rid of 30, 40%, 70% of humans being left to the wayside, but actually using technology to elevate humans. Whatever that's going to mean, and we're going to have to figure out what that's going to mean at the company level, at the society level, at the government level, but that's what I'm happy that what I'm hearing is that, you know, people are talking about the same way that you're talking and wanting to use AI for good.
I want to, so, I missed your first name.
Oh, Sam,
Sam, hey Sam, Rob. I just want to pin a note on that because I want to share, love to share. I think there is an analogy for what a society looks like post ASI. And I won't get into it now, but I would like to share it in a little bit. But Sam, Shen, you guys, you're in startups. Shen, obviously, you've got some really successful ones under your belt. You have like a front row seat as to the pace of adoption. And like you're saying, in a lot of industries, it is still, you know, vanilla flavored ChatGPT interaction. How have you seen that change over the last 3-4 months? And what do you think that vector is looking like? Because I know everybody who's an engineer is getting slammed.
Yeah, I think the problem with them is every time they see something flashy, they tried it, and then it's not what they think it is. For example, Cloud, which is open cloud, was the latest trend, right? A lot of them saw like the app, but then it's very hard, difficult to set up. Of course, all the influencer made it like, okay, you can make this. You see like people start scamming, right? Like you can make money on autopilot with like open cloud. There's a bunch of like scamming ads like that around. So I mean, like people like them, like you just like wave after wave of this kind of like fast trend like that makes them kind of disbelieve AI a bit. So they just go back with ChatGPT. At the end of the day, I think unfortunately that's what I see for most like normal people.
Right. Normal, we'll put that.
Yeah.
Sam?
I had an interesting point that quite resonates with what you were saying, David. Say David. It's interesting. 2 weeks ago, there was a startup competition at U of T. I was lucky enough to be invited as a judge there. It was students pitching their ideas. It was like 40 different startups, and it really reminded me that I think what's happening right now is not about that us. We're building tools to just replace human interaction. We are like replacing ourselves. We're shooting ourselves in the foot by building tools that is able to do what we used to as human, right? I think the pie is getting bigger. I'm realizing that we are getting more powerful to do things that we weren't used to do. We weren't used to be able to do before, right? One of the startups, for example, was like she founded a machine that is able to crawl in a certain part of the human earth that human was really having a hard time to travel to, and was able to like it was having some radars on it and cameras and so forth, and it was to find certain minerals that we were short of in Yukon, in Nova Scotia, in various different parts of Canada. So this is something that we used to be like having a hard time doing because there was no proper machine, there was no proper intelligence on it. Think of your actual device that you have developed, having radars and cameras and various other things on it, is able to go to like different mountains and find things that we were having a hard time finding. So the pie is getting bigger. We're able to get more things done as opposed to like just a year ago, right? So I think it's less of us less of us being worried about unemployment, of us losing our jobs. I think we're gonna get more of what was this whole planet able to give us. We're gonna conquer more, we're gonna dig more, we're gonna get more out of it. We're gonna be able to achieve more. And it's so by that, because of that, new jobs are gonna emerge. So I'm not saying we're not gonna ever have the problem of what Elon Musk said, universal income, everybody has to get paid like $5 grand or whatever to be able to live. I'm not sure if that's gonna happen in 10 years, but I think the pie is gonna get bigger. We're gonna be able to do things that we're never able to do. We are gonna be possibly go under the ocean, find things, and be able to cure cancer that we were not able to do, for example. That's what I personally believe AI should really focus on and solve.
Yeah, but if we want to achieve that, then we need widespread adoption of AI in all the industry from the bottom up, right? From the very low end of gathering resources, right? So we can gather more resources, we can go beyond Earth or bottom of the ocean, like you said. And then from there, we if we have more resources to play with, then we can do more. Right, like we can go to another planet, another solar system, right? So there's much more we can do, but I think it has to start with a more widespread adaptation of AI. Even I think Gary kind of white in their tweet about how less AI was adapted outside of coding, outside of like software engineering.
Well,
Yeah.
to be honest, many of it is a compliance like in your industry, right?
Yeah.
I mean, we sell to pharmacies as well. Like, there's a huge HIPAA and pipe and pipette out, whatever that is
Yes.
called. The compliance out there is like, oh, you're not compliant. Like, I'm really afraid of like possibly adopting this tool. So we'll see in a year or 2 or 3. It's the governments that have to sort of lubricate the path for us.
It is the government, and so I'll actually say, so AI looks very shiny right now, but if you actually look on the real ground and what people are still doing, if you go into a pharmacy office or if they go into doctor's office, they still use faxes. Like faxes are used everywhere, and that's a primary method of communication because they're really used to that, and they find that the analog means is actually really good for security.
Faxes exactly.
Pharmacies, and doctors, pharmacies and doctors, and there's
I faxed my wife, but she never got it.
yeah.
Guys, we gotta wrap up. We got
Oh.
Nick coming up next. I really do appreciate it.
Okay.
I put you literally on the spot. So I round of applause for you guys.
Active.
All right,
We're gonna, sorry, we're gonna make up, is it okay if I just share this image? Thanks.
do you think?
Thank you.
Thanks.
Thanks, guys.
Yeah, and then are you all set, Nick? Super, okay, 2 minutes. So I think we can see that as we are developing out these agentic systems and the pace of these harnesses to be able to create novel software faster and faster. To find, identify unlabeled problems and market opportunities continues to advance. That it's we are going to see the prices continue to come down. So as intelligence becomes cheaper, right? It became 40 times cheaper over the last 12 months. Once that happens again, 40 times cheaper. And as engineers, we're getting very, very good at stacking intelligence, metacognition. We're not asking, hey, find out about this sector. We're saying, hey, let's develop a panel of specialists to research this. And then we actually invoke a panel of specialists to determine who the specialists should be to conduct the research. So the metacognition is growing. As the cost of tokens come down, the metacognition increases. We find more problems, we get more creative. So the prices are coming way down. As intelligence comes down, so will the price of everything else. So what is that world like? The notion of techno-socialism and in a world where it reduces, the price is reduced to the cost of the resources, plus a little, for almost everything. And that's not a world of, I have employment in order to solve a problem that you can't solve, because these problems can be solved. So what does that look like? I want to give you one analogy for that. In a post-labor economy, when the human cannot provide value, economic value, either by labor or by intellect, in a competitive, economically competitive manner compared to AI or artificially driven robotics. And that day is coming soon. Well, if we think back 1,000 years, we all have our own histories. 1,000 years ago, in the winter, certainly in the north, we would live off of all of the hard work from the summer. We would plant, right? We would sow, we would tend to the gardens, and then we would harvest. And then there was a winter season where nothing could grow. And if we had peace from valley to valley to valley, and we were not in a condition of war, and our stores were full, and the grains were full, and we had now only the winter to enjoy the fruits of our harvest, then over the winter we made music, and we made art, and we celebrated with each other. There is a social and human state that is to sow the benefits of your earlier work. And we recognize that in people who are retired. They worked hard and now they have a pension, and then they can live out their years enjoying the benefits of their hard work during their young career. We recognize that investors who make successful, wise decisions and then live off of the dividends and the benefits of their investments. And we can start maybe to conceive of it as a society that we have collectively contributed the data, everything that went into the experiment of artificial intelligence. And if the reward from that is that services and labor is now able to be provided, all the turmoil can be addressed by artificial intelligence. And we're left to reap the benefits of the work that we did as a civilization, which was to accomplish artificial intelligence. I think that's something that we could find familiar. That's what I want to know.
I think what you're describing to me sounds like, I like the word altruism, and I'm not talking about the crazy altruism from like those guys at FTX. I'm talking about like actual altruism, like the idea of I want to make the world the world that I want to live in, and I want the people around me to treat the people around me the way I should be treated, the golden rule of sorts. If we can infuse that into what you just said, like, why do we have to work to live? Right? Like, I'm one of the lucky guys that gets to do what I'm good at, what people want, and what I'm appreciated for, and I guess I get paid pretty well for it. Like that, what more do I need? You know, and I think that's what you're describing, I think.
Yeah, that's right. Like, you wouldn't ask a successful retired investor, you have no purpose. You know, now they've had an achievement, and then they're able to live and do everything else they want to do. It's not labor for the purpose of solving scarcity. Because scarcity is eliminating scarcity. Is what could be the great promise of revolution.
I hope.
I hope so.
Now Nick, he's OG as well. So Nick and I hooked up at the University of Toronto Rothman School, where you and I were both advisors, and we've got both Pellick as our kind of he's our guy, right?
Yeah, he's a beauty.
Yeah, you don't know
Not your typical university professor.
Yeah, Bo's crazy. He was a professional basketball player at some point.
Yeah,
His son plays for the New York Islanders.
Yeah, better not make that mistake.
Yeah, he's a defenseman, right?
Yeah, and he's elite, so it's not just one of these French guys.
He's top.
Very successful investor.
Yes. So,
Yeah, we'll be working for him someday. Yeah, that's for sure.
yeah, he's a good guy, and that's so 6 degrees of Bo Pellick.
Yeah.
Nice.
So I built a couple of things, if you can imagine this, Sunday night. So to give you an idea of scale, it's possible. And one of my favorite hobbies is to actually get this guy in the corner here to look at Ruben's whole GitHub. And I'm like, okay, list all the GitHub repos in there and all the packages that are involved, and it'll never get them all, right? But it gets a fair amount, and then I say, okay, well, let's build something crazy, and then it gives me some like kind of surface level stuff. I'm like, no, like never been done kind of crazy, right? And then it gives me something more like what I want. So one of the ones I created was called Quake Vector.
I'm sure screen.
And it's, yeah, sorry. And it's, so this is. All right, there we go. Sorry about that, guys. Just need to share my screen there. So it can detect earthquakes. So it's pretty sweet, right? So you can just read that really quickly. I'm just gonna go through this fairly quick. I want to get to the fun stuff, not this like boring kind of explanation as to what it is, right? But it's a neuro terrain engine. So that's the graphic. Or I'm not gonna go on a full screen.
Full screen?
You want to go?
Yeah, using Notebook LM.
Yeah.
Notebook LM adding actual PowerPoint format. It's nice.
Yeah, so. Let me get this out of the way here. All right, so. Again, I'm not gonna make this a lecture or anything like that.
That should hide, just click off. Yeah, go up, yeah, cool. There you go.
There it goes. All right, so, okay, that's much better. So it's got, you can see it's got the RVF. This is all Ruben stuff, but it's just applied to something, right? So sub-millisecond latency is pretty sweet. The GNN, this is all inside of root vector. Sona, which is a previous project that Ruben created, but it's also baked into root vector. So this is kind of what we're doing now. Sorry about that. This is what we're doing now, this kind of slow, sensor cloud. It's not really real time, right? So this Quake Vector, yeah, it's a lot faster. So it's a sensor stream, edge native, and there's graph learning. This thing's pretty sweet. Then we get a predictive alert. You can see these three things are actually happening. Again, I'm not going to get into the physics and software, but it's essentially like a, physics attached to like real world activity here.
What it does, it takes the signal and creates a hyperbolic space. So think of a circle with a center point that spans in every which direction as similar to like what we saw in the Wi-Fi. And then it maps that signal in a multi-dimensional space. So it can understand speed, time, depth, whatever information, and those are all related to each other. And then the system is able to understand all the connected relationships.
Yeah, exactly, right?
Yeah.
And I'm fooling around with this stuff, but anyways, I'm not gonna go through a lot of this, but you can see I'm using root vector GNN, Sona. This is the root vector core that I've used, and then the RVF runtime. Again, I'm not gonna go through all this stuff, but you can see those are the core components. But let's get into the fun part of this, So.
How long that presentation take you?
About a minute or so. So yeah, this is the open source repo. You can see all the features here. It's got the 256 dimensional embeddings. A lot of it, this is very similar. A lot of stuff I built, you'll just look at Ruben stuff and be like, yeah, because it's very, very similar, because I'm following along, right? Just doing my best. So it's the repo, you don't need to see that. So, okay, so is it ready? Oh, there, okay, so earthquake. So you saw that this is simulation, obviously, but it's sort of taking a number of different what would be sensors, devices, etc. And it's got them baked in. So now it's like, it's sensing earthquake, and you'll see it blow up whenever it's actually saying, oh, there's actually an earthquake somewhere in the network. So there. So it's pretty crazy. But yeah, so you can see the event probability, and you can see probability timeline. So you can see like one of the sensors just visually. So yeah, pretty cool. And you can see them coming in here. So with actual sensors and network, this would work for real. And then, so this is not really something to worry about. Nothing to worry about. Maybe there's a high one in there, but once there's a high one that comes through, that's when you see that explosion at the top. So that was project number one on Sunday. Project number two was this synapse graph, which the earthquake thing I was excited about. But then when I did this one after, I was like, okay, this is the one I really like. So it's essentially like right now there's these brain computer interfaces. I'm not gonna get too far into that. It's something that's fairly new to me. But what I did find out was that there's not really like a very common, I'm sure it possibly exists according to Cloud Code. This is the first one ever. I don't know if I buy that, but it's certainly one of the few that exists. But it's essentially memory layer in between that brain computer interface and like a physical device, like a wearable, right? And so what they typically work like is every time the person starts this process over again, it forgets everything from before. It has to start all over again. So it's like, kind of like, what's the point? You know, like it's a very short-term understanding, whereas this is designed to actually create some sort of continuity in that process. So again, I'm not gonna go through this really, I'm gonna go through this really quickly just to give you some baseline of what it actually does. But you can see neural spikes, predictor, embedding, ingestion, cognitive mirror. Chime in whenever you want there, Ruben, but it's got a couple layers of LoRa's going on.
So the key to the brain interface, and there's been some breakthroughs actually this year in this space. And it's a NV diamond, what do they call it? An NV diamond quantum sensor. So, sorry, laser guy, yeah. So what's your name again? Shad. So Shad gave me a laser last month. And I was like, oh, it's kind of like, oh, my kids are gonna blind themselves with this thing. But then I get thinking, and like, oh, this is really powerful laser. This is kind of a cool kind of present. So I looked it up, and it turns out the thing runs at 580 nano, nano something or other. It's really tight spectrum, so it's tiny spectrum. So then I'm like, okay, Claude, what can I do with this crazy laser thing that I got here? And it turns out that there's this device that you get from AliExpress or Alibaba, and that called the NV Diamond Quantum Sensor, something or other. And it would use this laser perfectly because it allows it to sense the quantum vibrations in the area adjacent to it. My that's kind of crazy. Like, what's that all mean, right? I got a laser. And so it turns out that this device can actually detect these minor fluctuations. And it's particularly well suited to pick up on the electrical signatures of very microscopic things, such as the cells in your body and the neurons and synapses in your brain. And it doesn't, and it only needs to be in proximity to the thing. So basically, as weird as this may sound, it can like literally see these sort of structural energy flowing within your mind and in your body, in your cells, and create a map of all those things in real time. That's what he's describing. That whole entire thing I just described cost me $156, and I ordered a bunch of parts from China. Wow.
Yeah, so you can see here, just like the stateless, this is like status quo on the left, and then synapse graph on the right. So there's really like no personalization other than the actual session that the person's in. So this is a simple ingestion, processing, discovery, and output. You can see I'm using some of the same pieces of the root vector here. And
remember, it's looking at the zero. Whenever you see the stuff that we're showing you that's built in my sort of vector system, it's essentially making a map of what's not there to figure out what is there. And that's the hard part to get your mind around. Where traditional AI has always been based on what's everywhere, this is the opposite in every possible way. And that's why it works so well.
yeah, sweet. Okay, so edge execution. So this is where the devices comes into play. You can see the stack here. Let's get to the good play. Let's get to the good part. But you can see the foundation, the graph and temporal. You can see the different layers here. Graph attention base.
This is an important one. So the question is, how can my system learn by itself on a tiny little box that I was showing the size of a credit card? It's the attention. So what happens is within the graph space, you've got an interconnected relationship of information, right? And those signals, that can be health related, it could be mine, minerals in the ground, whatever. And what you're looking at in the structure is, again, the causal effect, this reinforcement sometimes referred to. But once you've got the reinforcement, think of like playing an instrument. The first time you play a guitar, you go from F to G to E or whatever, and it's a struggle. You're not sure where the fingers go. You're thinking really hard. It's like, oh, how does that sound? How do I strum? There's all these different things you're trying to do to sort of learn that pattern. As you do it more, you become more comfortable with that transition. That's trajectory. So in your mind, there are neural pathways. You've got sort of the neurons for the information and the synapses as the network that connects those neurons, right? The synapse is the network and the neuron is the storage device. Your nervous system has the ability to figure out where to get back to that moment because of trajectories. You think of it like muscle memory. I've done it enough times. I understand what the sound is when my fingers are in a certain place on the neck of my guitar, and if I strum in certain ways. So now you're creating a patchwork of different things that are happening in your brain. Tempo, remembered patterns, and trajectories. The attention allows you to understand those trajectories within the structure of data itself. And so every bit of AI, whether it's a language model or other forms of AI, is based purely on the concept of attention. The ability to reason or understand upon itself.
Yeah, sometimes, sorry guys, sometimes I've got all this like groove content floating around in my mind, and sometimes I'm forgetting that, you guys are not necessarily hearing Roof talk about this all the time, to the extent that I am. But, so it's got the routing adaption, so you can see Vector's router core, Sona is used again, and the edge WASM boundaries for it to be sent out. So I'm gonna go. Yeah, so this got the distributed neural mesh.
How'd you prompt it to be so pretty?
Yeah, this is just throwing in the description of what I used to build it and the actual components of what I used to build it.
And yeah, I see you're using a DAG.
Yeah. There's a DAG in there too. So
I can't help myself. So DAG, a direct acyclic graph, I think is what it's like that. Remember, a graph, a DAG is a sequential bit of information. Think of like multiple steps, do this, that, and the other thing, where a hypergraph is sort of goes in every which direction. So depending on the problem you're trying to solve, you might want to solve it through a series of steps. An agent doing this before that would use a DAG. GitHub is the most famous DAG.
Yeah.
And side note.
Yeah, and synaptic meshes in there too. So. Okay. All right, so this is the UI for it, because that's what people want to see. So it's like, here's your brain, here's your brain. Activities in the brain. Let's crank this thing up. So that's what it's simulating. So you can see the intent on the side. Really cool. There's a LoRa adaption on the left.
Needless to say, if you're doing any kind of brain scanning, whatever, consult your physician.
Yeah, that's right.
Medical.
Could use that little warning.
Can we get that $100 chip from Alibaba to plug it into our brain?
We're not far.
We're not far away, but.
In regards to Elon Musk and his brain chip and a few others, they're all using the sort of traditional approach to AI for these chips. So they're hot. Who wants a hot chip in the back of your brain? They use a lot of electricity. They have to literally be charged every 9 hours. That's less than my phone, and I'm sure that's on day one, which only gets worse. And they're based on, again, probabilism. So you're essentially uploading to a cloud or a device nearby to do all the thinking, all of which is crazy.
This is nuts, right? Like this would be like from your wearable measuring activity in your brain. Like it's
beautiful.
It's crazy. It's crazy, man. So yeah, 4 hours. Both projects, 4 hours Sunday night, like a couple days ago. A couple hours on the UI today. So 6 hours for both projects. Just to give you an idea of scale, like I use Rootflow to build this. I got a really dialed in way of building things.
Yeah, ADR.
Yeah, ADR, spark to ADRs.
Let's see it.
and
See your ADRs.
implementation.
I love a good ADR. Architectural decision record. It's the trick to building anything crazy. Like you're seeing like anything you can imagine, if you can
So
grab
here
it,
they are, here.
research the state of the art for X. Create me 10 ADRs and then build against the ADRs and the DDDs and it'll stay on point.
Yeah, so you can see them here.
So what's your first one?
3-tier temporal architecture. Just down.
So this is what keeps it grounded. This is how it can build. And then it can prove back to it later after you built it, you want to add to it.
Yeah, and I usually create a Spark specification initially. And then I tell it to look at the Spark specification and create me all the ADRs that I need. And then it'll get to a certain point and I implement them either sequentially if it makes sense, or I will actually tell it to give me like a series of prompts that shuffle the ADRs and DDDs for like what depends on what. Because sometimes I find if I do it in sequential order, there'll be some like disconnect between them. So that's just what works for me. But you can see like the coherence gating. Rube loves the ADRs. It helps a lot, especially if you already built something and then you're like, well, if something's not working or I need to add something, then you're just like create an ADR for blah, 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 blah. And then it looks at the whole project and creates a coherent plan. Then like Rube said, it's like, it's a decision record. So you can see and well, you can see, but also better, Claude Code can actually see what you built, what order you built it in. And then it can make a lot more sense of what it's doing. It's not like building random pieces here and there that are completely disconnected from each other. Then you're trying to wire them together and make them work. It sucks. Like we've all been there, in projects. So anyway, so you could see the proof gated graph attention. And this wasn't even that like a lot of projects will have like 30, 50 ADRs. Like this wasn't even that bad. And the reason being like I was using so much of what Ruben already built. And I made sure to tell it like which packages were involved. Well, I told our friend Claude browser extension to do all that work for me, right? But I made sure that it knew. So then it just made everything dependent on things that we've already built. So really it's like 7 EDRs in like an hour. And like I was kind of watching TV when I built this too. Like it's just a matter of getting these skills under control, then it becomes second nature.
Just a little comment about the brainwave analysis.
Yeah.
Like I saw the like 14 channel EEG
Yeah,
things
like
that you can put on. You can get them from China for like $300, or like there's some other companies for like 1,000. So I wanted to get one of those things. I was gonna hook up Root Vector to it. I just haven't got to it. Well, I haven't bought the EEG for it yet. But I wanted to run experiments while sober, drunk, and high, watching movies, different listening to music.
Exercise maybe might be on it.
Yeah,
Well,
plus like
if you're volunteering your brain, I'll help. I'll be happy to explore it.
incredible.
Because I think, what we can do, we can do transfer learning on that structure. So once you've trained it on, different activities with a baseline, like this is me working out, and this is me doing other things, then you can then take that as a trajectory and then look at other people and then make assumptions and then take those assumptions and combine them. So you only need like a handful of examples and then it's mostly what you need to know.
Exactly. And my wife, so that's what I wanted to do. My wife, she's a dental hygienist. She wanted to do like a study of dental anxiety versus non-dental anxiety. And I was like, oh, that's awesome. I can even make an app of like what tool you're using, or like an app for the patient to like, do you have anxiety to like kind of link with the brainwaves?
You can take a step further. So you don't mess with your brains, consult a doctor, blah, blah, blah. But you can actually mess with various forms of frequencies that are tuned to certain brain types. So literally your app could understand the optimal frequency to make someone less paranoid or unhappy by literally playing some background noise that they don't even realize they hear. And that could be in an ultrasonic frequency just above your hearing. And then you can correlate that to the brain path.
Yeah.
So Nick, I have a question. So actually the very first project you showed, the Quake bot. So right now in Japan, it's actually precarious situation because around every 100 years or so, they have a very big earthquake, which is called the Tohoku earthquake, which is the next one they're expecting. If it's probably going to hit around Tokyo, then there's going to be billions and billions worth of damage and potentially even more casualties as well as a result. But I was thinking that if you could actually use your software on a humanitarian lens, you can actually save millions of people in Japan if you are able to predict that the Tohoku earthquake or a big earthquake is happening in the next couple of hours or in the next couple of days. So
This kind of came from a little bit out of like a product that one of the guys from the Agentics Foundation is building with Rubens. You renamed it now. It's the Wi-Fi deep rooms.
Yeah.
And and it was review now. So I'm using all the OG names here, but you know, it's able to determine where people are in a catastrophic event. You know, where there was a hurricane that went through and people are trapped in rubble and stuff like that. So I'm like, could this be used for earthquake detection maybe? And Ruben said it was good, so you know, probably onto something that's.
We even did one for birds where we could detect the sort of various kind of causal effect of bird communication. And then it can pick up on things like whether it's a raccoon or the UPS driver. It's like what? They speak in signals. Who knew? I guess it's obvious now that I say it. But yeah, so and you can detect the causal effect of the signal of the birds communicating with each other. And it's actually relatively straight. And what do we call it? 7 cents? Is that we sell it?
I don't know. Every week, it's always something. Even sometimes we're just having fun, and like one of these projects, it was just like we're joking around, and then it was like one got like 20,000-30,000 stars or something where you were trending on X.
Yeah,
first on X.
Yeah.
It's so crazy, man.
But now it looks like your application, even just going to the earthquake one. There's so many other applications that
Tons.
you like, I can think of 50, like top of my head, and I'm not even on pod right now, but like, you think if you're able to anticipate a breakage before it actually happens, you talk about cell phone networks, you talk about human synapses in your brain, being able to detect possible stroke, all these kind of things. And then the commercial side of it is, well, beyond cell phone, but transportation grids, electricity grids, like there's so many applications just on that one little piece of technology.
Yeah.
And that's where I love is you get people like this, the groups here and a lot of the people that are talking about that they're releasing this stuff open to the world, so the big guys can't, or
Well, they can. They just can't charge
they can't
for it.
patent it. But that's in my opinion the first time in human history that the little guy, not even needing a garage, can actually release something faster than big multi-billion-dollar corporations that used to control all the inventions in the world. Now it's people like here and with the movement of open sourcing and stuff like that, I think it's going. I'm going on the Star Trek side and saying this is the good side.
Yeah, I think it's gonna be short-term pain and a lot of it for much long-term gain, and we're gonna be able to do anything. Like the guy that has that idea and you know, with all his buddies around or she or whatever, we're gonna bring those things to life, and they're gonna be 6-figure jobs for those people in that room that want to help he or she do that, or they do that, you know. Whereas now we all know you gotta go raise money, gotta go do this and that. So yeah, there'll be job loss short term, but long term we'll come out way ahead.
Anything want to present, discuss, shows, open mic sorts? Any comments, questions, concerns, terrified? Yeah, that's.
oh,
I'll add one thing, sorry.
oh,
I'll just add one thing to that notion. The opportunities, and Shannon, as you were talking about, like, and Sam as well, all the different things that can be done, and all the innovations, all the creations. Those are, I mean, effectively, those are exactly what you're saying. Either individuals with very small teams that are able to disrupt very large incumbents. Because very large incumbents, a lot of this are dependent on the sophistication of logistics, the delivery of services. So as we all need a significant amount of intelligence, we can craft those and manage those previously difficult challenges very as Ruben was saying, inexpensively, that's a tremendous wave of opportunities as we move towards the elimination of station. It's an enormous amount of help.
Sure.
So I see there's thousands of possible applications for the device and sort of everything. So what, one of the critical things though right now is there's only handfuls of companies that can, and locations that can make these computer chips. So I guess one of the things I was wondering is, is there a way to use those AI to come up with ways that can make the chips, production chips much cheaper than what it is now? We've got $1 billion clean rooms and so on.
So first of all, the chip that I've got coming out is on what they call a 12 nanometer die. So give or take for my 257, because I like prime numbers, cores, running at 8 gigahertz. So that's running on about 1.9 to 2 watts of power. So give or take a AA battery. And most of the time it's running much lower. That's peak. That means I'm cranking out all 257 cores at the same time. You know, it would consume about 2 watts, which is nothing, right? So I could pack tons of those into, let's say, a server box, right? These are 3 centimeters, right? So I could put thousands of them in there, and we run on about the power of a microwave, right? So it's 1,000,000 times less than a comparable GPU from NVIDIA and whatnot, H100 style, and it's $15,000, 15,000 times less in terms of cost. That's my prototype. This is lucky I have a chip designer that's my co-partner and co-founder of the company. Now, what gets wild is when you think about the shrinkage factor, and the only reason I'm doing that is because there was some well-connected guys out of Norway that were doing a chip, and I was able to sort of piggyback on the work they were doing. So I didn't have to go and raise a ton of money, no money actually, to get this chip developed, because I had Claude to help me do that and Roger. But where this gets crazy is when we look at the latest technology from Intel. So Intel last month, or just January now, came out with a new 1.8 nanometer die. 1.8 nanometer is roughly 9 atoms across. So think of the tiniest speck of dust or like sand on a beach. Now that can contain 257, potentially 1,000 plus cores running on static electricity in the air. So think of what all the things we've been showing you, this AI and the self-learning and all this crazy stuff that's now as small as a cell. What if you could put intelligence, and this is technology that's available today. We could create a 257 core version of this at the size of a grain of sand, but the technology is shrinking. I would need $250 million to get this done, by the way. So if anyone has 250 million laying around, let me know. I'll get this chip developed. But the size of the chip and the amount of energy being used by it is shrinking. And there's an atomic wall. The atomic wall, funny enough, is actually, it's the size between basically our reality and the quantum space, but it just so happens to be exactly the same size as DNA. DNA is in the structure that it is because it's the smallest unit of information that can exist that sits outside of a quantum sort of existence, if you will, right? So to get to that level of size, if things keep miniaturizing at the same rate we are, it's roughly about 10 years off. So in 10 years, hypothetically, if things keep shrinking at this rate they currently are, we're going to be able to have 257 cores that is literally the size and written into your DNA. So what's that do? Well, it does a lot. Turns out cancer mostly is minor mutations in your DNA. But more interestingly, when I started looking at the structure of the DNA itself, I work with a lot of healthcare companies, no pharmaceutical. I did a big project for Moderna, so I guess that counts. But anyway, when you look at the structure of DNA, it turns out the DNA itself was actually not the core storage mechanism. DNA was actually, if you want to use an analogy, a map and a key to a secondary latent space So when you laid out the actual DNA structure in a vector structure and style, it actually opened up a whole variety of other signals that weren't sort of obvious at the time. So think of it like this. Think of it like looking at a map that's 2D printed on the floor. I can see the map and it looks like a map. I can see the different tunnels and whatever, and it's a subway map or something. But when I'm in that map, when I'm on the ground in Toronto, looking up and seeing the buildings and the birds, it's the same thing from a different perspective. So when you think about DNA and when you map it to a sort of graph-based structure, now that I can understand and I can see the differences in the inflections in real time, I'm now at a point where I can infuse the very structure of computation into the very sort of reality and components around us. What does that do? Well, right, the most obvious is it can understand how to truly rewrite DNA. There's no reason for this kind of collection of entropy that makes us age and get older. Because now I know exactly what my optimal version of my DNA should look like. And I'll know instantly, because I've got my min cut and all the crazy stuff I was showing you earlier, to instantly tell me when one of my strands of DNA is outside of its acceptable bounds. And then, because it's a computer, it can literally rewrite that code on the fly. That opens up a whole other can of worms. Okay, so now I've got the ability to rewrite and understand, the very fabric of me and the world around me. I showed you Wi-Fi signals tonight. I'm showing you, I'm showing you that we are able to sort of reimagine what literally a year ago was unimaginable, right? Here's the structure of a real-time view of random Wi-Fi signals that are traversing your body and structure. Mind your sort of, I don't know, oscillations as the signal goes back and forth between going out and coming back to the receiver. Those little fluctuations, we can measure those and understand things from it. That's essentially seeing the unseeable, right? Now that is just a sort of glimpse into what the future looks like. I don't know if that answers your question. I just felt like rambling.
I guess one of the things I'm wondering is definitely miniaturization, some great potential there. But you get more, and that's sort of one direction. They aren't mutually exclusive in the other directions. But it doesn't have to be so small that it can be just mass produced so much cheaper. So whether
the cost
big or this big, if you could make it, cheaper by not having to get it so small.
Well, there's two things to remember. So as the size gets smaller. So let's just go back from crazy Futurama for a moment. If as the size shrinks, the energy consumption level shrinks as well. So you use a heck of a lot less power. Now, that's important for a couple reasons, right? One, at a super small size, it also gets way cheaper. So let's say this chip at scale is going to cost me $10 a chip, right? And there's some markup, whatever that happens to be. At 1.8 nanometers, assuming I have $250 million to drop, the actual cost of that chip at scale becomes pennies. So at pennies, that means every pixel in that TV behind you can have essentially a little brain in it. So you have a fabric of little chips that isn't just a TV anymore. That's a living understanding element that interacts with everything around it and understands you, and it's a TV. And it's cheap. At pennies per pixel, you can infuse it into every pixel of the TV. Or you can put it into devices that are truly smart and don't require any cloud provider. When I'm showing you this device is 100% self-contained. I don't need internet to run this. I don't need a cloud provider. This thing will run anywhere. Well, within the realm of -5 to about 50 degrees Celsius, but generally speaking, pretty much anywhere. And most of the time, it's not using any power because I've got a thermal optimizer that says I don't need to run most of the time. And if it does, it'll optimize itself for peak performance. And this is just the first gen. This is just my prototype that I'm showing you guys. Like, what does this look like in 5 years? Like, what kind of presentation am I doing then?
So would that be able to process video? Like
Yes, video
like now or in 5 years?
right now. So I can do any kind of signal processing. Now, video is an interesting one. So it depends on what you're trying to understand. But generally, for the types of things that I would use this for, video would act as a secondary grounding. So back to this example here. Now, if I want true high fidelity, so this is my interpretation of reality. This is actually a demo, right? But if I want a true interpretation of that reality, I would need to give it a separate perspective. That perspective could be video, images, and things like that, at which point I could get even higher fidelity. Because it understands both. Think of like the seen and the unseen parts of the world around us. This is interpreting the stuff we can't see, the radio waves at different frequencies. Now, keep in mind the way frequencies work and why this works is at low frequencies, I can penetrate further and go further. So think AM radio, ham radio, shortwave radio, right? Shortwaves, they go far. They can go through materials much more efficiently. They're low fidelity. Right? They don't include a lot of information, but then go far. If you think of Wi-Fi, you've got 2.4 gig, and you got 5 gigahertz, generally speaking, in other two. You use 5 gigahertz because it's a high fidelity. You keep the Wi-Fi rather close to your TV and you stream video on it, but it's not going to throw the signal across your house. It's got a short sort of range because it's a high frequency. So similarly, what I'm doing here is I'm using the different frequencies ranging from very low to very high, combining them into a kind of mesh, and then saying what's different in that mesh. That's what pops out. What you're breathing and how fast you're, what you're moving. It can then detect, is that person in that waiting room, panicking because their heart is stopping? Are they panicking because they're just, scared for whatever reason? And it can pick that out of an audience. So take it a step further. Let's say we're at a concert and someone is overdosing in the bathroom. You know what? That happens very frequently. And what happens is they overdose in the bathroom and no one knows because there's no camera in the bathroom. You can't put cameras in a bathroom, right? But with this, you would know instantly that there's someone struggling in that bathroom stall without a camera. I can detect the signs that their heart is slowing, their breathing pattern is anomalous, and I would never need a camera to see that, and I could save their lives by administering, the appropriate response to that problem. That can happen in an elderly care facility at night. Someone's breathing and struggling. No one knows because no one's checked on it for 2 hours. Well, now I do, right? So there's so many of those types of use cases, that are perfect, like seizures and heart problem that can be detected. I could put this in my house and it just monitors my house using, Wi-Fi signals. And it's always checking and saying, is anything out of the norm? Oh, we've noticed a weird sort of, gait to your step. Well, you know what that means, potentially? It means that there may be signs of, early onset dementia. Changes in how you walk actually indicate that you might have cognitive impairments of various sorts. All those things can be detected because most of the time it's just been studying me dormant, just understanding the ideal version of me on a $131 device. Yeah.
This sounds like there a similar problem that was actually with technology before. So the same technology was made in order to identify this whenever behavior was different than the norm. But what would happen is that people wanted to find out like whenever there was anomalous activity, but instead it picked up when people started exercising or vigorously doing some activity, and that was different than the norm as well. But you end up with more false positives that are not giving you the information you want.
Looking at what it was, what it is, it's the one. That's the problem. We're always looking at what it has to be and not what it isn't. And that's a perfect example. Like what it is could be many things, right? It could be me working out, me doing, getting excited because of whatever reason. And what I'm really looking for are the sort of the other side, right? When is it out of that spectrum, but in a way that is potentially dangerous? Like, so think of like back to the analogy of empty space, an intersection. Most times the intersection is generally empty of things. There's cars going through it. The occasional person crossing the street. I only care when there's potentially something really bad gonna happen. Let's say a child is outside of the visible range of the car, because the car it's a truck and it can't see below now I've got a sensor on all the street lights in the area, creating a grid. And it understands, well, in a normal situation, a child crosses the street and it's got a mother, it's seen, it's a certain distance. Now, in this scenario, the system's smart enough to learn, well, this is outside of that pattern. I'm going to suddenly put all red lights on because there's a potential child that might get hit. Now, I didn't tell it exactly how to learn that. It learned that by itself through a kind of causal loop of an extended period of signals that it was able to study within the structure of this intersection. Yeah.
So I'm just curious, in a situation like this, or like the Quake bot, you have to establish a baseline first. Presumably, if you're doing something like this, where you're kind of mapping people in a room, it's gonna be different in a different room, like if it's got a reflective floor or whatever, so you need to get a baseline. How long does that take? I'm sure it's different in different.
So that was one of my first problems I had to solve here. So what I did is I used transfer learning. So once I get a baseline for certain problems, again, I'm showing you the different transfers that I'm doing here. So these are different mechanisms I use to sort of learn the structure, right? So in this case, I've got a crowd, or I've got, different options here. So once I can learn the structure, I can then pass those and apply those to other areas as a kind of like, like when a bird flies south, it kind of instinctively knows how to fly south. It's never really been told, and even when you separate it from a flock, it somehow knows to fly south. That's a kind of instinct. So I can train the system to have those initial instincts, and those instincts are the kind of baseline for what it needs to do going beyond that. So now I've got a security system, and it generally knows what an intrusion looks like versus friendly activities and things like that. But then it's learning sort of beyond. So it's kind of like a baby taking its first steps and then learning like as it sort of goes. This is an incremental learning system. It isn't like a pre-training where I take a language model and I say, here's all the information in the world, train, done. And it doesn't change. This is, here's what you need to know, and incrementally over time, it's going to get better. Studying, understanding things adjacent to what it needs to know.
Is that the Sona?
So it's a series of things. So Sona is the self-learning neural network architecture. I love acronyms. And the real trick is a combination of something called EWW, whatever. It allows you to basically understand and remember. So it's the same mechanisms that language models use to sort of when they're fine-tuning and training the model to remember the most important parts. The difference is I'm using that on an ongoing basis. That provides the ability to, again, incrementally tweak the models ever so slightly when things are learned or need to alter because good or bad or causal effect. There's a whole series of crazy under the hood that makes it happen. But the most important part to remember is it's working in the structure of a kind of vector graph attention space, that round ball of information that I was describing.
But that's completely different than like normal, where you see a million faces before you understand it's a face. So those kind of learnings were
Generative AI.
Yeah.
So there's generative AI generates the most probabilistic output. Language models, image models are generative AI, right? And you give it a question, print me a picture of the Pope with, holding something. It'll generate that. Now, mine is a contrastive model. My model doesn't look at the generative output of something. It's not trying to create. It's trying to understand through mathematical bounds. So it's contrastive. It's saying, what's the contrast in the component to understand what it needs to do? So it's not perfect for everything. It's not, you're not going to use it. You're probably not going to use it for generating pictures of the Pope or whatever. You're going to use it for understanding the life of the Pope and the important parts of that life. What were the points in his life that were most, that led him to become the Pope? I'm going to be able to understand the trajectories, these interconnected relationships of really complicated networks in a way that's real time and simulated across many different bounds. So now I can simulate a question and get a most probabilistic result saying, how can I make the future that I want for this particular company or this decision, this particular decision, and then simulate all the possibilities of every decision that's meaningful and have that guide me to that result. So it's a different.
Or kind of like driving a car, you don't have to know what the AV looks like, you just have to know there's something.
Yeah.
About, what about manufacturing? Like use for that. So one of the areas we're looking into is in steel making. And it needs to be very consistent, right? But it needs to be caught when there's inconsistency.
Diamond NV Diamond, Google that. Ask Claude about Diamond NV quantum sensor. If you want to, if anyone's working into sort of, oil and gas, minerals, pharmaceuticals, medical, this, in my opinion, is probably the biggest breakthrough, other than my MinCut thing, that we've had this year. And it's room temperature quantum sensing at a femto scale structure. So that means whatever femto is, like sub-cellular level. And you could crank that stuff out. So do what Nick did with one of those devices. You'll reinvent entire industries, I'm sure.
So you call it
NV Diamond, that thing is, I can find it here. I've shown you it before. This was inspired by the laser. Yeah, I go down weird rabbit holes. I'll show you guys after. I'll send you a link to it. I bought mine on AliExpress. Maybe I'll bring it next month.
So we have maybe 2 more questions, we have to make sure.
Oh, yeah, okay, yes. When it's mingled for the last few minutes then, is that, or any final questions?
You
All right, you go.
Roughly per chip, what coverage square footage?
About 30 feet and about 4 people, so you're gonna need a bunch. But the good news is each chip costs $1. So you can spread these out, basically to work great, you need, remember, in the systems I make, you gotta remember to always use odd numbers, preferably prime numbers, 3, 5, 7, and you're gonna get a better result. My system's based on a kind of irrational structure, based on, again, an optimal number of 7 and a constant of prime. Prime is a known constant, it goes basically on forever. And what that solves in my system is the tendency for quadratic systems to have resonance. So when you look at computing, you see 2, 4, 6, 8, 16, 32, 64 as sort of the structure of most computing systems. The drawback to that structure is it has a tendency for errors to propagate in a resonance, a harmonic that kind of repeats, which makes the system inefficient. This system, because it's based on prime and odd numbers, means that the system is completely deterministic, so you don't have that weird resonance you get from 2, 4, 6, 8, and so on. Just remember that. We're done. That's all the brain I got to give.
Well, thanks Ruben, thanks everyone for helping out, and the people that were up here, we'll stick around for a few more minutes. And don't forget, on Saturday is Pi Day, so make sure.
Pi.room.io. You can plug into it now. It's kind of crazy. Ask Claude what you can do with it.
Yeah, thanks very much for coming, everyone. We'll be back here second Tuesday of next month, and thanks for our presenters and guests that came up. And there is more.
And title scale for always being our gracious host.
Yes, Tribal, thank you. See y'all, thanks for joining.